Good evening, everybody. Am I audible?
Yes, ma'am.
Okay, let's just wait for a few more minutes for more students to join and then we can start the session.
Ma'am, is this a question solving session or summary session?
No, we'll discuss week 5 concepts.
Okay.
Ma'am,
Yes.
ma'am, I have one question doubt in qualifier exam.
Sorry.
I have one question doubt in qualifier exam.
We'll take up doubts at the end. I'll try to cover the concepts of week 5 first because that is what the session is scheduled for. If there are any doubts, I'll take it up in maybe the last half an hour if time permits.
Okay.
I'll just be starting in 2 to 3 minutes because I think only 22 students have joined. Let me wait for some more because usually around 50 students join such sessions. So,
Some doubt.
sorry.
Can you take some doubt?
Yeah, that's what I said, right? I'll take doubts at the end of the session. After the agenda for the session is completed, I'll take doubts in the last half an hour if time permits.
It can be solved in 2 to 3 minutes because not many
I
people come.
agree. Maybe, yeah, I agree. Maybe your doubts will be solved in 2 to 3 minutes. But if everybody starts asking doubts one by one, it will take around 15 to 20 minutes at least of the session. So I can't pick whose doubt to solve and whose doubt not to solve, right? So we'll first start with the agenda for the session because in the schedule, this is supposed to be a week 5 session. So we'll cover those concepts first. Otherwise, even week 5 will be left. And anyway, for doubts, I think the TA sessions are also there. So maybe those can also be used for help. But either way, I'll try to take up some questions towards the end. Even if some week 5 concepts are left, I'll reserve the last half an hour for questions. Is that okay?
No, ma'am, a doubt from quiz 1.
Yeah, that is what I'm saying. The quiz 1 doubts, I'll take it in the last half an hour. Okay, I think I should start with the session. Let me share my screen. Is this screen visible to everybody?
Yes, ma'am.
No, I think this is the first lecture of week 5, right?
Sorry, your voice is not audible.
I think this is the first lecture of week 5, right?
No, I'm not able to hear you properly. Can you repeat yourself or write it in the chat box?
He is asking that is this the first session of week 5?
Yeah, this is the first session of week 5.
Okay.
I'll be starting week 5 from scratch only. The only understanding required till now is week 1 to 4. So basically, this was week 1 to 4, right? I'll just reiterate very quickly here. In the week 1 to 4 revision session also, we discussed basically the table, how a table format is created, what are rows, what are columns, the records are in rows, the attributes are in columns, what is the difference between an attribute and a variable, what is iteration, what is filtering and accumulation, what is a function or a procedure that we call it, how to pass parameters, how to call a function, what to do, how many parameters can we pass, does a function has to return something or is it not necessary. All these things were discussed. What a pseudocode is, how to write a pseudocode from the flowcharts that you have. So this is basically a very quick topic summary of what we had learned in week 1 to 4. Now the main agenda of week 5 will be that introduction of, first of all, what lists are. So till now we were handling something called a single variable, a variable which either took an int or a string or something like that. But what if we want to store multiple things in one particular variable itself? We don't want to create multiple variables to store some information that we want to hold. So a collection of multiple things when we want to store in one variable, that is when the concept of list comes. So that is what we'll be discussing. Just a brief overview of what the agenda is for today. So why are lists needed instead of basic variables that we had? What notations do we use for lists in specific to our particular course that you can expect? What is normal list notation, how to append in a list, what the plus plus sign does. If you've already gone through week 5, you'll be somewhat aware of these things. How to build lists from a table if you've been given a table, how to iterate over a list. Let's say a list is basically a collection of different things, right? So what if we need to access some particular thing from that list? How do we access that? All the utility functions that are there for using functions of basically utility functions for lists. Then we have how to use multiple lists together, nested lists, etc. So these are some topics which are there in week 5. We'll see how much we can cover today, at least in the first 1.5 hours. I'll try to cover as much as possible. And as discussed in the last half an hour, I'll try to take up some questions related to the qualifier or week 1 to 4. So I'll be creating, till now, I think you might have noticed a pattern that I try to create some data set for the session, something different from what you've been seeing in the sessions, or no, not the sessions, basically the videos or the data sets that have already been provided to you. So I try to make up a dummy session to make it a little more interactive, because I think the other data sets you've already seen a lot. So I'll be doing the same. I won't be working with the food data set that we had till now. I'll be creating some TechFest data set for the purpose of week 5 at least. And based on that, we'll be continuing. So I'll create a table. You can visualize it to be a card data set also, or I'll be basically considering the table. So my notations for the pseudocodes will be in the form of a table only. Okay. So let me see if I can just try to copy paste this, maybe, though I don't think so that will be possible. Okay, if not, I'll just write it itself. Oh great, I can. I'll just need to space it a little bit. So considering this data set, we have ID, we have name, we have branch for the students. Also, I would like the session to be somewhat interactive. This is something that I have said multiple times, because since I am here typing on Excalibur, it becomes difficult for me to understand if you guys are able to hear me properly or not, or if you guys are even present, or have I left the meet by mistake, or some network issue has come up. So I'll just keep speaking here without any assurance from your side. So that does not make too much sense. So I would request all of you to please participate.
Okay.
Okay. So let me change the color for this. Yeah. Is this visible to everybody?
Yes, ma'am.
Yes, ma'am.
So I'll just go through this data set once, just to show you what all is there. So these are the attributes that we have: ID, name, branch, year, city, coding, quiz, gaming. what is expected of you guys till now is that you are able to tell the data types of these things. You are able to differentiate what all operations can be done on which all things here. But we won't be going too much into that because that has already been discussed heavily in week 1 to 4. This time we will focus on how to create lists from this data set. So as we can see here, the data set has ID, it has name of the student, it has the branch which student is from, it has the year which the student belongs to, the city, and there are 3 different, just like in your scores data set, we had maths, physics, chemistry, right? Similarly, here we have coding, quiz, and gaming. So basically, you can consider this to be a tech fest setup that students had a tech fest in their college. So an ID was assigned to them for that particular fest. You can consider it to be the unique primary key or something for this particular data set. Then we had the name of the students, the branch of the students, what year they belong to, what city they belong to, and what their score was in the coding round, the quiz round, and the gaming round. So assume that in the fest there are 3 types of competitions that were held. One was related to coding, one was a general quiz, and one was a gaming session. So in all of them, each student has a different score. And based on that, we'll try to create some problem statements which will help us to see why we need lists. Right. So one off the top of my mind, one thing could be we can try to group these students by either year, branch, or city. Right. Let's say we want to compare how the CSE students, the average of the CSE students is working as compared to the ECE or the Triple E or ME, or how are students from Delhi performing as compared to the ones from Chennai, Mumbai, or Pune? How are the first years performing as compared to the last years? Something like that. Okay, so these are the kind of problem statements that can be expected. Moving forward, okay, so first of all, is the table clear to you guys?
Yes. Yes, ma'am.
So now a
Yes, ma'am.
typical problem statement
Yes,
for
yes.
variables. Problem statement for variables. Now let's say we try to hypothesize a problem statement for variables. What could it be? Somebody give me a problem statement in which a variable will be used in computation related to this table. Anybody?
Maybe counting who has scored the maximum marks in each of the coding, quiz, and gaming conducted.
Yes, that is a good problem statement. So we will have how many variables in that?
For each of the subjects, we would maintain a max.
Yes. So max marks in each category of competition. So this will have 3 variables. Yes.
Yes, ma'am.
Anybody else?
We can also say that how many students are came from like which city or which branch has been scored well in the quiz.
Okay, when you say which branch has scored well in quiz, what is the parameter for scoring well? Your first one was correct. You're saying that,
It
okay,
should be like relative to the someone, or it we can give also the categories between above the 90 or above 95.
yeah, that is correct. So first thing you said was how many students were present in from each city. So here again we will have how many variables?
4 variables.
So for this case, we will have 4 variables because we have Delhi, Chennai, Mumbai, and Pune. Now, this is a very small snapshot of the data set. You understand this, right? No data set will have just 5 members. There'll be at least 100, 200 of students in each data set. And we don't have a cap on the number of cities allowed. It's not like we are saying that, okay, only 5 are allowed. So if you try to look at it from a perspective of how this will pan out when the data increases, do you think it will be feasible for this particular thing to be solved with variables? The first one, I agree, it can be solved with variables because we know coding, quiz, gaming, these three categories are only there. That is what we have defined in the data set. Why? Because those are the attributes. We know there are three attributes. But when we talk about the possible values that any attribute can take, we are not sure whether how many are possible or not, right? Especially in a example like city, this is not something categorical. This is not something like there are only three, just like we saw in the previous examples, right? The spice level, there were three possibilities. Categorical variable was there, but city, there could be multiple cities. We don't know the maximum cap on the number of cities possible in this data set. So in this case, what you're defining is how many students were present for each city. We will have four variables for this snapshot of the data set. But if we talk about a bigger data set with, let's say, 100 values, it could have at least 20, 25, or 30 cities. Do you think it will be feasible to have 30 variables then?
No.
Right? This is where lists come in. Right? So one particular list, it will act as one variable, and in that particular list, we can have 30 entries. So there could be a list called cities or count cities, where index of each particular list will denote, okay, which city that person is from or something like that, based on our definition, what we want to define it as. And it can store the number of students. Understood?
Yes.
But to be honest, this problem statement is more suited for dictionaries, but we'll come to that later. Don't get confused with that. We'll see suitable problem statements for list also, not necessarily this one, but more suitable problem statements. Okay?
Yes, ma'am.
Okay.
Okay, so this was one. Now we will come to, okay, we discussed why this is not suitable. Okay, so this much we've covered. Next, coming to, so somebody said, okay, we need to find out the highest marks for each of them. Now the thing is, in highest, we are only considering the marks, right? Or at max, the student with the marks. What if I want to consider all the marks somehow? What if I want to remember all the students who are from Delhi? In this case, they are just two. Okay, so that's all right. Let's say we had a lot more here. I want to remember all the students from Delhi in the sense that I want to hold all of their marks in a list format. That, okay, in coding itself, otherwise, if I talk about students from Delhi, you see, I'll have to create at least 6 variables only if I consider coding, quiz, and gaming, right? Are you able to understand this part? Why? In coding, I will have coding student one variable for each student, right? So coding 85, then coding 95, then quiz 70, quiz 91, then gaming 90, and gaming 72. So 6 variables will have to be made just to store each and every information about the competition for Delhi students only. You're able to understand this?
Yes, ma'am.
So how can we reduce this? By forming lists. For lists, we can have that, okay, for coding, all the students who are from Delhi, we will keep appending that particular score to the list. And then it will be one list with 85, 95, and even if more are to come, the list will remain one. Maybe one for quiz, maybe one for gaming. So similarly, it will decrease the complexity of what we are trying to do. Okay. So we could I'm not writing a pseudocode here for now. I will do that later. But let's say this is what I'm talking about. Just a second. Or we can also think of this as sum of or average of marks for each. So let's say this is what we have here. Okay. So Delhi students, we have defined a variable here itself, but this variable is not a single value. You can consider it to be a list. We have defined this list. Delhi students here is a list. which contains, let's say these 4 values. Okay, this is from a bigger data set. So for this one, I will consider it to be, let's say I want to Delhi students, and what I actually want to write here is the problem statement to be sum of all Delhi students across the competitions. Can you please mute yourself if you're not speaking anything? So Delhi students are there, sum of Delhi students across all competitions. So first one will be what? 85 plus 95 is what? I'll write it
170.
I'll write it one by one so you understand what exact values I'm referring to here. So first is Delhi 85. You're able to see my cursor, right?
Yes, ma'am.
So first we have
Yes,
Delhi
ma'am.
85, then we have Delhi 95. This is for coding. Okay. Then we have, or let's say we can even define it. Okay, the coding, comma, quiz, comma, gaming. So for the purpose of this one, we have defined this as coding, quiz, gaming. So first one, we had the sum for coding. Then for quiz, we have the sum as 70 plus 91.
91. Yeah.
Then for the next one, we have the sum as 90 plus 72.
72.
So now we have some values here. Now we try to, okay. Just give me a second. Is my voice clear to you all? I think I'm noticing some network issues.
Yes, ma'am.
Yes,
Yes,
please.
ma'am.
Okay,
It's
good.
clear.
Now, so yeah, now what we want to do is we want to find the sum. So 85 plus 95 will be 180. Right?
Yeah.
Yes.
Then we have 70 plus 91. So that will be
161.
161. Next we have 90 plus 72, which will be 162. So again, close call between quiz and gaming, but coding is clearly, Delhi students are scoring the maximum in what? Coding, right?
Yeah.
So among Delhi students also, we want to find out that what did they perform best in. So sum of all Delhi students across competitions. So students are performing the best
We
in.
have completed our 30 days challenge. Then what do you think? What should we do now? Should we post like normal, or we should post some?
Can you please mute yourself if you're not speaking in relation to the session? Yeah, okay. So now we have got a list where we have the sum of marks for Delhi students across coding, quiz, and gaming. And we have already tried to define that the order in which we are adding things are coding, quiz, and gaming. Okay. So now I'll try to iterate through these things. Now, again, this order that I have defined in this case, we are doing it manually. But again, like I said, this can be done better using a dictionary also. But for the sake of an example, because this is not what I'll be using necessarily in a pseudocode, for the sake of this example of how a list is, I'm trying to define. Sorry. Please mute yourself if you're not. Just give me a second. Yeah, please mute yourself if you're not asking any doubts. So now within this list also, we can find out the maximum. We can try to go through each and every element of this list, and we can find out that in what particular thing the Delhi students scored maximum in, right? Now that is again another keyword that we'll be using for each or something, for which we will find out the maximum. So basically it is possible for us, given a list, to find out which particular element is maximum or minimum. Just like we do for variables, right? We iterate through different cards of different cards of the particular pile we have, and we try to find out the maximum and minimum, right? Similarly, a list can be thought of as a collection of some variables which we have, and we can find out the maximum or minimum amongst that. Okay.
Order is important for the list.
Sorry.
Order is important for list.
Can you please speak a little bit more clearly?
Is order is important in list?
Is anybody else able to hear them clearly?
Ma'am,
Can they
like
repeat?
they're saying that order is important or not?
So in this, ideally it is not. In the example that I have given, order will seem important, but then again, this is just a coding quiz gaming example that I have given. So in the future examples, and based on the things that we expect of you in this computational thinking course, order will not necessarily be important in a list. Okay, they will just be collection of elements. Order will not be important. Okay, just ignore this one. So let me just write it here only. Or rather, what we can do for this particular example itself is, rather than sum, right? Delhi student across, let's say, coding I'm talking about. Because ideally list should not be having any particular order, at least in the scenario of things which we are discussing here, right? So let me try to rephrase it to avoid any confusion. So it will be 85 and 95, right? So even this is a list. Understood? If there were more students here, then this list would have continued. So now in this, we know clearly that order is not important, right? We don't want to know which student was which. We just want to know the overall marks of the student so that we can do some computation with it. Let's say now using this particular list, we can find out the sum of students. What all we can find from here? Okay, yeah.
The performance of students from Delhi in coding.
Yes, this list can be used to find the sum of marks of sum and as well as maximum, minimum, average of marks of students from Delhi in
Coding and quiz.
only coding. Right now,
Sorry.
this is only for coding.
Yes.
So Delhi students and I will coding, right?
Yeah.
Similarly, we can have one list for and another for gaming. So initially, what I had tried to do in one list itself, right? Ideally, in the case of a list, we should do it using 3 different lists. That was just for the sake of an example. So we will have Delhi students quiz, we will have Delhi students gaming, and then each one will have, let's say, the quiz one will have 7091 value, the gaming one will have 9072 value, and then using that list, we can do a bunch of things which I have written here. Can be used to find out the sum, maximum, minimum, average, and other things also, right? And then we can compare those values. So you understood this part. One thing was that, okay, we try to do it iteratively using, so we go through the cards again and again and again. We try to find that value, and then simultaneously we keep a sum, max, min, or average variable. But let's say we don't know what we want to find right now. We don't know what we want to do with the data, but we want the data separately. In that case, we can have a list to keep the data where the order will not be important. Okay.
Okay.
So everybody understood this? Right. So just give me a second. Okay. Now let's say another good problem statement for this could be, one more problem statement I want to do for this is that let's say there are multiple students with the same marks. In that case, keeping a variable for each student becomes tedious. It's very impractical, right?
Yes.
let's say in this particular data set itself, I try to modify this value to be 72. To be 72. Now, let's say I want to find out that in coding, which all students have scored the minimum marks given in this particular data set. So ideally, what we will be doing is we will, if we talk about just one variable scenario that we used to do before, what we'll be doing is we'll go through the entire list of cards. We'll find out x dot coding. We'll compare it with the next one. And if it is less than the next one, we'll keep storing it. So the first iteration, we will have 85. Then we will have 91. We will not do anything. Then we will have 72. And we will try to save, let's say, the ID of this particular student. So 103 we saved in our variable. This is what we used to do. Everybody is following this particular thing that I'm trying to narrate.
Compared to same category or different category?
No, we are just talking about coding for now.
Coding only.
So I just want to find out the student who has scored the minimum marks in coding.
Same marks or minimum? Same marks.
Can you please repeat?
Hello.
I think your voice is not properly, either it's not audible to me or
Consider mark is same
can you try
category
writing
or
in the
different.
chat box? Can you please try writing in the chat box?
Okay, now hearing. Hello.
Yeah, I'm not able to properly hear you. Please try writing in the chat box.
Okay, I will try.
Same variable compared to marks. So I'm not properly able to understand what you're trying to ask here. So, okay, I'll just try to explain my problem statement once again, what I was trying to say. The scenario is rather the problem statement that I'm trying to share here is find the students or student or with minimum marks in coding. Okay, across all cities, across all branches, across all years, and find the student. So student basically means ID. I want to find out the name or the ID of the student with minimum marks in coding. Okay, this much is clear. What the problem statement is?
Yeah.
Yes.
So this, what do we do? Now, whenever we have such a problem statement, what we do is we
The
iterate
value
through
minimum
the
to
cards. We iterate through cards. We keep two variables. One is minimum marks or min coding, let's say, and the other is the student, right? Who scored it? Let's say minimum student. Minimum coding mark. This much is clear. We'll keep two variables. We'll iterate through the cards. We will keep updating variables by comparison. Now let's say while doing all this, we if you try to do this through for this particular data set, right, you will notice that initially we will have 85 as min coding marks and 101 as the minimum student ID. Then we'll compare it with 91. We will do nothing. Then we will compare it with 72 and update it. The marks will be updated to 72 and the student will be updated to 103. Then again we will compare with 95. Now in the end we are comparing it with 72 again, but a variable can only store one value, right? A variable
Yes, ma'am.
can only store one value. So now, which one do I store here? The second one or the first one? Both of them have scored 72. I need the information of all the students with based on the IDs who have scored minimum in coding. So here clearly see the minimum is 72, but more than one students have scored 72. I want to store all of them, right? So instead of having a minimum coding marks or minimum student ID here as a variable, we have it as a list. So minimum student ID will become a list. So solution for this is right. This
What
one
is
is clear.
student ID?
Sorry.
Can you brief about minimum student ID? I did not understand.
So minimum student ID is the ID of the student who has scored minimum. So minimum coding marks is there, right? Usually in this problem statement. Yeah. So it's the student referencing the students. So ideally this will then be 102, or sorry, 103 and 105.
105.
Right. So this is what we want to store. Similarly, it could be the same for maximum also. Let's say in quiz, we want to find out who scored maximum 92, which we have. Let's say this one, instead of 88, this one was 92. So same problem will come up here also. So you guys understood, right? Why we need lists, first of all. This was the purpose. Why lists. So this part was answered. Why we need lists.
Your voice is clear.
Can you please repeat?
Your voice is
Everybody understood this? My voice is not clear. Is it better now?
Yes, now it's clear. Because your voice is clear.
Yeah. So all of you are able to understand why we need lists. This is very important. For the basis of week 5 is the need for lists, first of all the other things are what we do with lists, what all possibilities are there, what kind of utility functions which we have, the kind of notations we have with lists. But what is important first of all is to understand why we need them. That much is clear to everybody?
Yes, ma'am.
Yes, ma'am.
Okay. I am copying a pseudocode for you guys here.
Your voice is breaking.
Ma'am, your voice is
So
breaking.
Your voice
sorry,
is breaking.
my voice is breaking. Okay. Is it better now? Because I think my network is stable enough. If it breaks
Yes.
again, just please let me know, okay? I'll try
No,
to.
ma'am, your voice is pretty clear.
Okay, maybe it's a network issue with some of you guys. So if you guys can try switching or reconnecting, that will be good. Okay. So let's continue. This much I hope is clear with you. I'll be copying one particular pseudocode for you guys, and then based on that, I will introduce the notations required for lists. I'm not keeping this particular session too much heavy on pseudocode because I feel all of that is very clearly defined in the slides. If you just go through the slides once, right, the need and everything is very clearly defined. There are exceptional pseudocodes already written there, so I won't be focusing too much on that because that will take up a lot of time. Maybe in the next session those can be discussed. Today I want to cover the breadth of week 5 first, giving the notations required, the need required, and maybe one or two examples. Okay. So a simplest we talked about why we need list. Sorry, yeah, somebody was speaking.
Why we need this?
That is what I explained for the last half an hour, right? So given, I'll just try to briefly summarize this once again.
sometimes what happens is whenever we are trying to keep some variables, keeping one particular variable is not enough. Let's, for example, this problem statement that we discussed, it says that we want to find out the minimum marks as well as the students who scored the minimum marks in, let's say, coding, in the coding parameter of the competition. And while we were iterating through this particular list, we saw that two students have scored the same marks, which are minimum. So now, if I talk about the conventional variable, which we had been talking about for the first 4 weeks, it would be difficult for us to understand which of them to our variable. But let's say we want to store both of them. In that case, we will use a list. Basically, a list is an example of a collection. Okay, so I'm talking about the list here, but what I'm a broader sense is a collection. So in the future, we'll see multiple other collections also. There'll be dictionaries, there'll be lists, there'll be other collections. But the need for a collection or a list being a simplest form of a collection, which we are seeing right now as an example, is that we want to store multiple things in one variable itself, or assigning one particular variable, in this case minimum student ID, to a set of or a collection of items. But earlier we were storing it as one particular variable each. So for this example, we would have had to store two variables just to figure out who the minimum student is. We would have student 1 or student 2, minimum student ID 1, minimum student ID 2. But that is not a feasible approach. So we try to create a list in which we don't have a cap on the number of items which we can store in this. Clear?
Yeah. Yes. Yes. Yes.
So that it has a sequence of values, and a single variable name is used to refer to the entire sequence. So we don't have to get confused between student 1, student 2, student 3. It's students, and then there is a students. So we will go through the notation and pseudocode a little bit, and some operations that can be used to manipulate lists. So, okay. So I was going to attach a pseudocode here, or rather, let me. Okay. I have some pseudocode with me, but I'll have to modify it a little bit. Let's see. I'll try to put it here.
Hello, ma'am.
Yes.
Can we store more than one type of variables in this list? Like name, marks?
So ideally, yes, it totally depends on the definition. So in collections, yes, definitely you can store multiple types of things in one particular collection. But for ideally, if you talk about lists in other languages, then yes. But it totally depends on the statement that you have defined. If in your problem statement you need multiple types, then yes, go for it.
Okay.
Okay, just give me a minute. Okay, so for this itself, right, let me have a student IDs. This is the list that was initialized. Yeah. Then my pseudocode says while I want you guys to fill this out. This is very basic now. While we are talking about a
Yes.
table, then what do we say? While
Table has more rows.
table has more rows. While table has more rows, what are we doing? Read row. Let's say X. Right?
Yes.
Read the first row.
Also had one more variable. Minimum coding marks. Let's say 100 I'm assigning everybody assigns why, everybody is understanding why I'm assigning this as 100, right?
Yes, ma'am.
Maximum marks.
I think some of, yes, maximum possible marks. Now, what will be next? We read a row from X. Now, what are we comparing? Come on, guys, this is basic. You just yesterday gave an exam for this.
Minimum quoting marks greater than student ID dot marks.
So first of all, we'll be using if minimum coding marks is less than. You can have
Shouldn't
both.
we check if it's
Yeah,
Less than.
depending on the problem statement, you can either negate that also. But yes, if coding marks is greater than dot
Coding marks.
right, then what do we do? First of all,
then coding
we
marks is equal to x dot coding.
minimum coding mark
X dot code.
is equal to x dot coding. But again, here I want it to be greater than equal to, because in that case where it will be equal, right? Even in that, I want to store this particular person. The next thing I'll be doing here is minimum student IDs is equal to minimum student IDs. Oh, just give me a second.
X dot coding.
Plus plus x dot ID, right? So this is the notation. If we want to append anything to a list, right, we use this plus plus and then we add this particular in here. We'll discuss this in detail. This is just an introduction.
So, ma'am, here you make it greater or equal to.
Yeah,
Then
I made it greater than equal to here because I want to add students who are equal to, right? For in this case, initially we would have had 72 in 103. So we would have changed minimum coding marks to 73 in that particular example. Let me add it here with another color. We would have had 73 here, right? And the other one would have been, at some point, it would have been 103.
So that means that here the maximum mark can be. So here the maximum mark can
No,
go
not maximum.
above 100 also. Means the marks
How can
can
it
be
go above
obtained
100?
more than 100.
No, it can't be.
As you mentioned here, no, 103.
103 is the ID. These are the IDs of the students. If you notice here also, 103 and 105, हम लोग basically, the purpose here to find out who has scored that, right? We want to find out the student, not just the marks. So who has scored that? Therefore,
no, the
to store the
conditional
IDs.
statement.
क्योंकि minimum marks तो 73 ही होंगे उसके लिए.
नहीं,
Yes.
आपका ये जो statement है, conditional statement, the minimum coding marks, the minimum coding marks is 100 here. You make it greater or equal to. Then if it is more than 100, then only in the conditional, the body of the statement, the code will go. Otherwise, it will skip here. It can be less or equal to, but if we make it greater or equal to.
No. Why will it skip? See, try to run it once. Minimum coding marks is 100. We read a row X. If minimum coding marks is greater than equal to whatever coding marks we have here, currently 100 is greater than 85. So it will enter.
No, suppose here the X coding marks might be 85. Suppose X dot coding marks is 85. Then what will happen here?
X dot coding is 85. That is what we see the first one to be, right? So what will they compare here? So it will compare 100 greater than equal to 85, which is true. Since it is true, it will enter.
Okay. There was some confusion. Okay.
Right? Since it, yeah. So since it will true, and then after it updates it to be 85, it will update the student to be 101. But then this will keep on happening, and at one point we will reach 73, 102 to be the minimum. Now next, what will happen? Sorry, 72, 103. Now what will happen is when we reach the last line, at that time, we want to add that person to the minimum student IDs list, which is there, right? We want to add that person. This much is clear with everybody. That was the whole purpose of the exercise, right? That we want to add that particular person. But if we have only greater than here, we will not be adding that, right? Only when we have 72 greater than equal to 72 true, only then we will enter this. We will again, minimum coding marks is equal to x dot coding will remain the same only, it will be 72. But in minimum student IDs, I will this time append this particular student. If I would have just put greater than, then we would have not entered in that case and 105 would not have been added. You understand this? Right?
Excuse me, ma'am. Hello. Excuse me, ma'am. Ma'am, like I have a doubt here.
Yes.
Like suppose the first marks is 85. Like first x dot coding is 85. So the minimum ID will be 101.
Yes.
Then the minimum student ID that will store 101, no?
Yeah. No. Yeah. At that time, okay.
101, and then next again it will be executed. So it is keep on adding that part, no? Because every time it will be less than 100. What I'm understanding here.
Yes.
Correct.
Yes.
Or
Correct.
Exactly. Nice catch here.
Correct. That's what I also I am like, because each time it will enter the every number there.
Yeah. Okay. So we will have to fix that here. Yeah, I missed that. My bad. Thank you for pointing it out. So every time this gets updated, right? Every time min coding dot x dot coding gets updated, what we have to do here is we can have a can you please mute yourself? We can have one condition here saying can you please mute yourself? There is a lot of noise from somebody's end. Yeah. Kushal, can you please mute yourself? Able to find that name of the student also in the participants. Yeah, Kushal, can you please mute yourself? Can you please mute yourself? There is a lot of noise from your end.
Yes, ma'am.
Yeah. So here, in this case, maybe we can have some small condition here, which says that rather than doing it here, right? One more thing which we can do it will be a little more. This is not the most optimal way that we can do this, but just for the sake of clear understanding, I'm trying to show this here. So first, what we'll do is we will find out the minimum coding marks. Okay. This much is clear. First, the first point of action here is to find out the minimum coding marks. for this particular table. After that, now this will introduce one more keyword for you. After this, what I want to do is, okay.
Excuse me, ma'am. That process we can't do. Like we can move one in the table 2, and then we can compare, and which one is the minimum. Then we'll take that by comparing, something like that. What we are doing earlier.
Earlier, so basically what we want to do here is that whenever we have minimum coding marks, we first want to find out what is the minimum coding marks, and then based on that, we will add minimum student IDs.
The
Right?
first
So
execute this if loop. After executing this if loop, we get the minimum coding marks.
Yeah, so no, not just if loop. We have to execute the whole while loop because I want to first go through the entire data set once
Each
to
row,
find
correct.
out whatever minimum is there. Then again, we will have this loop. Let me just copy paste it here. Again, not the most, there might be more optimal ways here. While table has more rows, we will, and if in this case, the marks are equal to, because we have already found out the minimum coding marks, right? So in this case, whatever min code marks has, it is already 72. The value is already 72. We check if they are equal. In that case, minimum student IDs plus plus is equal to minimum student IDs plus plus x dot ID. This is clear now? So in this first, what we are doing is this whole section. Just a second. Find the minimum marks. So this is finding the minimum marks. And then here what we are doing is update the list. Okay. So in two sections, we could have done this in one also. In one while loop also this was possible, but again, it would have been a little more complicated. So let's go with the basic right now. Now let's say.
Hello, man. Am I audible?
Yeah, you're audible.
But the while loop will be continuously going on. They are not changing any table.
Again, your voice is not properly audible. Can you please repeat, please?
The while loop is continuously going on. We are not changing the table from one table to another table.
No, it has while table has more rows, right?
Yes, we are not moving to any village.
Okay, so you're saying that like we say that okay, in the end we say right, they put this into pile 2 or something. But again, when we are talking about a table, we just talk that okay, it has more rows. So when I'm assuming in this that okay, when we are reading row X and then we are moving to the other one, we are already basically here. This is an assumption only from my end that read row X, then update X to next row or something. Okay. But again, I think when it comes to tables, this is sort of taken for granted. When we're talking about piles, it is one particular step that we are keeping it in the other pile. But when we're talking about tables, once that particular row is gone, the second while loop, it is automatically the next row. But we can write it if you want. Okay.
Just one thing from an understanding perspective. The first block which you have written of if minimum coding, finding the minimum work marks, right? So that creates one table.
No, it is not creating any table. Table is already there. We are going through the table and we are updating the variable called minimum coding marks. And then when we find out the minimum coding marks, then in the second while loop, again, we are not creating any table. We are updating the min coding marks, min student IDs. We are updating the min student IDs based on some condition of min coding marks.
We are
Is
not
it updating
creating
in
a
the
table.
same table or same?
The table is the same only, right? There is only one table which we are referencing to here.
Excuse
What
me,
we are
ma'am.
updating is
But
min
then
student
where,
IDs.
correct, but where it is getting updated?
Min student IDs is the name that we assigned to this collection, right? Is a name which we have assigned to this collection here, the first line. So this is getting updated. This empty list which we had earlier, it is getting updated, and at the end it will 103 and 105 as the answer.
Okay. And it doesn't
Yeah.
need that return thing, right? Which we had seen it in
No,
the.
this is not a function. It's not a function right now. This is just a pseudocode.
Okay.
Excuse me, ma'am.
Return is
Excuse me,
a function. Yes.
ma'am. Ma'am, excuse me. Hello.
Yeah. Please go on.
Ma'am, like the first if loop, like while then if condition is there, then we are ending that if condition. So where you have written update, no, update X. So there, if we write like minimum student ID is equal to minimum student ID plus we'll means append that one list. So I think we'll get the result there only, because
Yeah, this
there
is
we have ended.
exactly what did. This is exactly what we were doing. And initially, I had missed that point. We had done that, and then somebody pointed out correctly that when we are doing that, when we append a list, right? Even if
Yeah.
so, list is
No,
not getting
actually,
initialized every time.
I was only there. Because before this append was inside the loop. If we'll keep the append outside of the if loop, I think it will store the minimum marks. So no need to write the second while loop. I
No,
think
why,
so.
why will it store? We will have to somehow put
Just
this
ma'am,
inside the while loop.
one thing can you do? This one appending one, can you copy and paste it over that part? Update one over there. Can you paste? And then you can see that how it will be executed.
No, I don't.
Down
If
one.
you
Just
have, yeah, if you have
no,
this
not
there,
if condition, not if condition. Just minimum student one. Yeah, this one line.
yeah, even if you have this there, right? So
Yeah, ma'am.
assuming that this is here next to update X to
Just
next
copy.
row, what will happen is try to visualize what will happen.
Yeah,
Even
what I'm
so we are
understanding.
updating min coding marks. That is okay. So we updated
Yeah.
min coding marks. Let's say we had 72.
Yeah.
Okay, let's start with the beginning. Let's say we had 85. We updated min coding marks to 85. Then we are coming out of that if loop anyway, right? We are coming out of that if loop. And after coming out of that if loop, 85 will at least be appended. Min student IDs will have 101 no matter what. Then after that, it will check with 91. Okay, it will not get updated. But again, 72 will get updated. Then again, 72 again will get updated. For this particular data set that you are saying, the answer will be 101, 103, and 105. But for some other data set in which marks are already in descending order, in that all of them will be added.
Yeah, got it. Again, it will be means keep on. It will be added down. If you'll keep outside the if loop, then
Yes.
also no
Yes.
effect will
That
be
is
there.
why
Yeah.
in this case, the best option is to have different while loop for understanding purpose. Because my purpose here is not to understand the logic, but rather show the purpose of lists, right? Otherwise, if you talk about it in one while loop, it is possible to keep this inside somewhere. Every time we are updating this, right, we will try to maybe keep a flag or something, and we will check that if we are entering this list and this is getting updated somehow. If we are entering this, then inside this if itself, we will try to we have to first check that the minimum coding marks and the X coding marks should not be equal. Then they should be separate, and in that case, we will have to initialize this min student IDs again. Whatever is there in that, let's say 101 was already there, we will first have to remove that 101 to empty the list, and then again start appending into it from scratch. It can be done with one also, but again that will complicate the logic, and my purpose here is not to complicate the logic of this pseudocode, but rather to explain why to use a collection,
got
right?
it,
Or how
got
to
it,
use a
ma'am.
collection.
Madam, suppose here as the example says that 72 is the minimum marks, but 72 has two candidates. 72 is obtained by two candidates. So if we execute this loop, it looks like these minimum coding marks. After executing this loop, minimum coding marks is the 72. It assigned.
Yes.
But this how this minimum coding marks to assign to the two students ID.
That's what we
Two
are doing in the
students.
second while. Check whether the minimum coding marks is equal to the row that we are reading right now. If it is equal, then we know that that particular student has that minimum marks, and then we are appending that student to the list.
No, that is okay, but you execute this upper while loop, and after executing the whole while loop, what it does, the student ID 105, this will be updated. This is
No, it
72.
will not be updated. Why will they be up? So the table is as it is. We are not updating anything in the table. We are only updating the minimum coding marks variable which we have, and that will get updated to 72, right?
Means this X, that is the last row. This 105 is the last row, na? So this X will represent this 105. And when you mention this X dot student ID or such kind of thing, so it will pick the 105. That's what I mean. It seems like this.
Yeah.
Then how we get this
So
103?
these are two different while loops, and when we start a different while loop, when we start a different while loop, it will have a different X, right? So X will change. X will keep changing from 101, 102. Whenever I'm doing update X to next row, X will keep on changing from first it will be 101 in the first iteration of the loop. Then it will become 102. Then it will become 103. That is how it is changing again and again, right?
No, till all the rows will be completed.
Static in all the iterations.
Means while we mention that table 1 has more rows, that means until and unless all the rows are executed, the while loop, the code will not exit from the while loop.
Yes. So first we go through all the 5 rows in the first while loop. So this particular while loop goes through all the 5 of them, and we find out one particular thing from that. Then the second while loop begins, and we start from the beginning. Now table has more rows. Table is as it is. Table has more rows. This is a new row X here. So this while loop and this while loop are not executing together. They are executing one after the other. So this X here is different. You can just to avoid confusion, right? We can have
that is okay. That means in the first executing the first while loop, it assign this X will assign to the 105. This is the last row, and it will just check this minimum coding marks is equal to y dot coding. Then what will happen? What is
then
y
after
now?
that, no, what is y now? As in we are reading row again, right? Table has more rows. Table is as it is, right? We are not removing any rows from the table. We are just updating it. Table is there as it is.
It will compare the minimum coding mark. That is, it will compare the 72 with all the rows again.
Yes, yes. Okay. So this much is clear to everybody. Now, in this, you might have noticed we did something called this particular line, plus plus y dot id. So this brings up the question, what all other such things are there? So this, you understood, we are appending this particular element to the list which is already there. So now, coming to what all other possibilities are there?
Madam, what does it mean, this before plus plus, and anything, any syntax is there after plus plus also means?
Yeah, we'll come to that.
Achha, okay.
Okay, so some simple things I'll be writing here. Just give me 1 second. Now this we know is an empty list. Right now, no element is there. Some other example of list which we saw is 101, 103. This was again an example of a list. Another list could be some characters also. Let's say I wanted to save the names. So in that case, Kabir and Ish. This is also a list, right? These are some examples of list. If I talk about how to initialize an empty list, what is a fill list, and everything. Now let's say I already had an example of a list. If I talk about here rather, let's say I have something called a dummy list, and right now the values I have assigned are 2, 6, 9, 1. Okay, 2, 6, 1. 26190. Okay, this is currently a random list I have. What if I do dummy list equal to dummy list plus plus 3? What do you think dummy list will be now?
3 will be added in the last.
So the new list will be 26190 This much is clear to everybody. This is what we were doing initially also.
And what if we use only single class instead of doubt?
Sorry.
What if we use only one class?
That is not the syntax, right? The syntax itself is 2 plus.
Okay.
1 plus is for addition. When we talk about appending at the end. Okay, this is a. So when we try something at the end, this is the syntax which we are using. If we want to append something in the beginning, then a separate order will be used here. So let's say I have a list is equal to 4 plus dummy list. In this case, what will be the response for the dummy list? It will be 4, 2, 6,
61903.
2, 3. So this much is clear. What plus
Yes,
plus
ma'am.
does? This is what, if I talk about this. This is appending in the appending in the start.
Hello,
So
am
this
I
is
audible?
clear. Yeah, you're audible.
But in list, it is irrespective of order, right?
Sorry.
List is irrespective of order. We can add anywhere now.
No. So ideally, what we are trying to do in a list can be irrespective of order. So when I say, right, so what I meant when I said that order is not important here is when I was talking about physics, chemistry, and sorry, not physics, chemistry, coding, quiz, and gaming, right? So in that case, if I want to have that particular order in terms of what we are doing in a list, that is not the kind of order which we are trying to preserve. But let's say I want to add something in the beginning, in the end. In that case, that particular order, whether we want to add it to the start or the beginning, that can be preserved. That is in our hands. But let's say we when I talk about a card thing, right? So we are going through that particular pile and adding something in a particular order. That order may or may not need to be preserved, because again, that in that we are following maybe the whatever the order of piles is there. Are you understanding the point? That pile itself might be shuffled. In that case, we can have a list, but it will not be in some particular order. Is that clear? Maybe you'll understand it a little better when you see some more examples in the end.
Okay.
So there are two types of orders, right? One is we may be talking about order itself in that particular list. A list has 5 numbers, 5 to 1. Are they in order or not? The other is that we are trying to say we have 3 categories and we are trying to preserve the order of those categories. So those are two different things, right? We can do the second one also, but we can't ensure that throughout. or maybe in that particular problem statement, that was not the most optimal way to go about it. For those kind of data, we have a separate collection called a dictionary. We don't use a list. You'll see dictionary in the upcoming weeks.
Okay, ma'am. Thank you.
Okay. So now this is what we did when we were trying to add one particular list to another list. Using the second list, we were making it on the spot. So this is a list only, right? So this is how we are appending an element by making by first making a list itself. Let's say I have another list, dummy list 2, and this has values 6, 2, 0, 1. That's it. Now if I do dummy list P is equal to dummy list or dummy list plus dummy list 2 plus we won't do here. Why? Because this is a collection, not a normal which we can do plus with. So plus is very important. In this case, dummy list 3 will be what? Who will tell me this?
Both lists will be combined.
Yeah, both lists
4, 2,
will be
6, 1,
concatenated.
9,
4261903
3,
6,
6 to 0, 1.
0, 1. Right? This much is clear. Now
Yes,
we
ma'am.
have first we were extending L, whatever list we had, with some item appending at the end. Now in
Can you
this we
explain
have
again, ma'am?
appended
I'm not getting.
two lists. Okay, just give. Till what part was it clear?
So, ma'am, if we enter only plus, then what will happen?
The plus basically means addition, right? Syntax itself will be wrong. For example, if you are adding two numbers A and B, A has 10, B has 5, and you do A plus B, then that doesn't make sense, right? Because 10 plus 5 will not give you the correct answer, right? So depending on what you are trying to work with, what variable or what collection you are trying to work with, that is how you use these symbols which we have, plus, minus, plus, things like this, right? So when we're talking about lists or one list with extending an element to that particular list, we use plus.
Can we check two
Okay.
lists, that is, are they equal or not?
Yeah, we can do that also. We'll come to that later.
Okay.
Okay, so we talked about extending a particular list with an element. We talked about appending two lists together. Now coming to how to process a list. We got a list, we obtained a list. Now this is our dummy list 3 which we have. Now I want to go through this list, right? I haven't made this list just for the sake of being in a list. I want to go through this list. I want to do something with it. So now in order to go through the list, what we can do is we can use a keyword called for each. So what we do in for each is, if I talk about one particular syntax of this, for each x in dummy list.
Ma'am, please can you explain that part again?
Which part?
Ma'am, that you're writing in the green thing.
Yeah, for let's say we have obtained a list already. So in this, let's talk about the earlier dummy list which we had final 4261903. We have a list, but now we want to do something with that list, right? The purpose of having a list is to process it, right? To maybe get something out of it. Correct? That much part is clear, right? We
Yes,
have a
ma'am,
list
I
of
got it.
certain things. Now, how do we go through that list? Iterate through a list. When we had piles of cards, we used to iterate through it, right? We used to have first one, we used to put it in the second pile, then second one. So similarly, here we have a collection of something. A list has different variables, values assigned to it. Now we want to iterate through these items. How do we do that? So we do that using the for each keyword. For each X in dummy list, some operation. Care about what operation we are doing right now. Some operation we are doing for each X. Let's say I want to find out the sum. So sum would be, let's say here itself, right? A very big, I don't look for a particular logic in this, that what this represents. Sum is equal to sum plus X, let's say. At the end, sum will be the sum of all these. Okay. So this is
Okay,
something
ma'am,
which
thank you, I got it.
Yeah, so this is something which we can do with lists. So here we are processing something. Now again, this is for each. You see how for each is very similar to the while we had while, right? So we had also studied that for is also a possibility. Similar to while, you see in while also we are iterating till a certain extent. Till table 1 has more rows, we are iterating again and again and again. We are going through that loop. Similarly, for each also, you see it's very similar to while. For each X in dummy list. So first we go through 4. We will do sum plus 4. Let's see how sum is getting changed here. So sum was initially 0. Then what we did was sum is equal to 0 plus 4. Then in the second iteration, it became 4 plus
2.
So similarly, then it became plus 6, then plus 1, then plus 9, then 0, then 3. So this is how it is changing. Right? This is how sum is changing. That much is clear, right? Any
Yes,
doubt till
ma'am.
this point? Do you guys have any doubt till this point?
No, ma'am.
Okay.
No, ma'am.
Okay. So this much is clear. Now coming to one thing is that inside while also we saw that we can have multiple while statements. Maybe in week 4 you might have seen a little complicated structures. Similarly, for each also we can have nested things. For each X in dummy list, we could have again for each X in dummy list, and then we could have checked it. So if you have already gone through the contents of week 5, this will be very intuitive and clear to you. But if not, I would suggest go through the videos once, because this it will help you understand this much better. But essentially, what we are trying to do here is that we have one particular for each nested for each, right? For each inside another for each. So okay, so how many of you remember or are already aware of the concept of of nested lists?
We will use it for comparison.
Sorry. Yeah, we can use that for comparison. So the purpose that we'll be using it for will be comparison only. So coming to an example, right? If we have to compare various marks, so again, I won't go too much in depth because last half an hour we want to discuss some questions also. So for the next 10 minutes, I will try to teach you some syntaxes related to this. We won't go too much into a pseudocode. We can do that in the next session maybe. But if you go through the videos, you know that we were talking about top 3 marks, right, in subjects. Similarly, in the example we saw, we can also have top 3 marks in coding, quiz, and gaming, right?
Yes, ma'am.
So for that, we will have to keep 3 variables, right? Maximum variable, a second maximum variable, and a third maximum variable, that too for each subject. Correct?
Yes,
You
ma'am.
remember procedures, right? For each subject, we are doing essentially the same thing. So we will make a function or a procedure. And then for that, we will, as a parameter, we can pass coding, quiz, and gaming. And in the pseudocode, we will have maximum marks, second maximum marks, and third maximum marks, right? So in order to do this, let's say we have created a list. So initially we were just talking about the marks. Let's say we want to find out the students for that particular marks. So we can initialize lists for each subject. That a coding list, we have a quiz list, and we have a gaming list. 3 separate lists which we can have. And then for each row, we can find out similar thing we did. I'm not talking about something too complicated here. Whatever we did here itself, right? I'm doing this for all 3 of them. This one was for coding, right? I'm trying to do this for quiz also and gaming also. So we will have 3 separate lists now. Are you able to follow this? Guys, some participation. Hello, am I audible?
Yes, ma'am.
So this
Yes,
part
ma'am.
we did for coding, right? Now let's say I do this for both quiz and gaming also. We will have 3 lists. One was 103, 105. In the second one, let's say it will be 101, and in gaming it will be 104 or yeah, 104. 3 lists we will have.
Yes, ma'am.
So now let's say we want to compare these 3 lists among themselves. We have already gotten all the students who scored the minimum in coding, quiz, and gaming. Now let's say we want to find out students. We want to check whether one particular student was scoring least in all 3 or at least 2 of them. That did the student who scored minimum marks in coding also scored minimum marks in quiz or gaming? Or was there one particular student who scored the minimum marks in all 3? Coding, quiz, and gaming. This is how we can categorize students. Correct? This problem statement is very important. Is it clear to you guys? And this is not a new problem statement. This is actually the 3 prize problem that I'm trying to discuss with a subtle variation. There we were talking about maximum marks. Here I'm talking about minimum marks. That is the only difference. Otherwise, you have already seen the 3 prize problem, right?
Yes, ma'am.
So this is what I'm talking about. Instead of prize, you could consider it to be who needs extra classes more.
Okay.
So first, I just want everybody to confirm whether this much is clear, because this is the basis. This is essentially week 1 to 4. I have not introduced any week 5 concept in this, at least the last 5 minutes that I spoke. Okay, no response from you guys. Okay, so we will be creating separate lists for each, and then we can use those lists to compare with each other. Let's say I already have 3 lists of how I talk about, and now I want to find out who scored the least. So in that case, amongst those 3 lists, we will compare these lists with each other and then form a new list to find out the common items. Let's say here, I have dummy list 2 and I have dummy list 3. Now I know dummy list 3 and dummy, okay, rather than this example, let me take a separate example itself. So I'm applying this particular code for 3 students. Okay, let's say we had coding min. This was 103, 105, right?
Yes, ma'am.
Let's say we have quiz minimum. Quiz minimum is what? Who scored the minimum in quiz? 101.
1.
Okay. And then we have gaming minimum.
Gaming minimum.
Let me change
104.
data set a little bit. This is 104, right?
104.
I
ma'am.
want to have 105 as common, let's say. So let me change this to 70 now. Now it is 105. Let's have one more 70 here. Instead of this 95 here, let's say I'm seeing 70. So again, 103 and 105. Okay, not this one. Okay. Let's say 81. Instead of 81, I have 70 here. Now this will be 102. 105.
105.
right? This is what we have. I'm bringing this towards the end here so that I can work with it with a little bit more space. Okay. So this is what I have now. 3 lists I have. For each X in coding min, right? Minimum marks in coding, let's say. First, I'm comparing 2 things. For each X in coding min, again for each. This is what we call nested for each. For each, let's say Y in Quizmin. If X equal to Y. Then what do I want to do? I had one more list, right? Coding quiz min. Somebody who has scored minimum in both coding and quiz. This is what I want to find. Then coding quiz min. Plus plus X or Y, because X and Y are same,
Yes, sir.
right? Now for this particular example, we won't be finding anyone because there are no common. But let's say we were doing it for gaming, coding and gaming. Okay, for that I want to run it once. Let's say I had this. Let's say I have this particular thing here. How will this go about?
Will this append a list of gaming?
Sorry?
Will this append
No.
the list of coding gaming?
Yeah, this will append the list of coding gaming, but with what?
It will
Let's try run
find
this
the
once.
common.
Minimum.
Yes. Let's
Yeah.
try run this. Initially, this was empty, right? I will try to keep updating it again and again as and when it. Okay. So I'll be updating coding minimum as it updates here. Initially, it is empty, right? Right?
Yes,
Yes,
ma'am.
sir.
So let's go about this one by one and see how this updates. For each X in coding min. So X is 103. So we enter this loop. Now we go for each Y in gaming min. So right now X is
102.
103 only. Let me also compare the value of X and Y here. So X is right now 103. Y is what?
102.
102.
102.
We compare, it is not the same. We again go to for each Y. So Y gets updated to 105. Right? So the inner loop will execute first here for each X in coding min, for each Y in gaming min. So X is fixed to 103. I tried for Y is equal to 102. It was not the same. Then I will try with Y is equal to 105. It is again not the same. We will do nothing. We will go back to the second line, which is for each X in coding min. Correct?
Yes,
So
ma'am.
now what is X updated to?
105.
105. Now Y is again 102. Again not equal. We will not do anything. Now again we will check this. It is equal. This particular thing will become 105. Clear?
Yes, ma'am.
So when this becomes 105, we know that there is a student with the ID 105 who scored the minimum in both coding and gaming.
And gaming.
Yes. Now, let's say we want to find out if there was one particular student who scored the minimum in all three. Let's say 105 scored the minimum in this also. Again, I'll have to change it. Assume that that is the case. And let's say in Quizmin also 105 was present. In that case, we will now compare this new list, which is already the minimum of 2, with the Quizmin list. You can understand why? Because if they have already scored minimum in 2, they are in this list, right? Now I
Yes,
just
ma'am.
need to compare this list with Quizmin, just like the three prize problem. Now we will
So,
consider
ma'am,
this.
ma'am, we can only compare two lists at a time, right?
No, we can compare 3 also.
Means we can do
It's just the
equals
amount
to
of
equals
how many for each. Yeah, you can have and here also, right? Let's say I had one more for each here, and then I would have done y equal to z, and then updated something. It will increase the complexity for sure, but there is no limit to how many nested for each we can have. I'm giving this example with a very basic scenario where we have 2 for each in nested, but we can have multiple for each x in coding min, for each y in coding min only. Right now I checked with a different particular list. We can have the same list also in multiple nested iterations. Again, this is a very problem statement specific thing.
So, ma'am, we can't use like x equals to y and that equals to z, right?
We can
That
do
will
it
be
like
wrong.
this: x equal to y, and or let's say this particular syntax, whatever syntax which we are using. Let's say we are using and, right? Y equal to z. This is correct.
Okay, ma'am.
Okay. So this is about nested. So, okay, nested is done. So you understood, right? How we can compare everything. We made one particular list here. Now we will compare this new list with quiz minimum to find out the overall minimum student. Now coming to the functions which are possible on a list. I will try to imagine a list is there, and then based on that, what all functions we can perform on that list. Okay. This is the last part. I will try to skim through this a little quickly, and then maybe we will pick up the questions. We had so I have length. Well, let me try if I can copy paste something here so that will be easier. Yeah. Yeah. So these are some things which we have. Let's say L is 379015. Okay, random. What is length of L here?
6.
Length is length is the number of elements is equal to 6. This is the number of elements in the list. Got it? Next we have first of L. First of L is the
3.
3.
First of L is 3, which is the
First
first
element in the list.
element of the list. What is last of L?
5.
5, which is the last element of the list. Now what is rest of L?
7901.
So rest of L, whatever we have given as the list, right? Rest of L is always everything except, first of all of the other ones you see were elements, right? They were particular numbers, 6, 3, 5. Rest of L in itself is a list. So we have 7, 9, 0, 1, 5, which is basically everything except the first. So from this we can say that first plus rest. So L is always equal to first of L as an first of L is always a number. So when we are appending, we will have to put it in the as a list first, and then rest of L is a list itself. This one also will be this. You got this part? This is very important.
What about
sir.
last element?
L is first of L. First of L was an element, right? So we will put that into a list and we append that in the beginning to the rest of L. So this will give us the actual list. Similarly, L is also equal to init of L plus last of L. Now, how does this work? Now, this init of L is what? Whenever we have something, everything except the last. So here it will be 37901. This is basically everything except the last. And this brings us to these two things which are there. How do we get the initial list back from this? Now, let's say I say, again, this is an exercise for you guys. Tell me what the answer for this would be. First of init of L. What is the answer for this?
3.
Okay. What about last of init of L?
1.
So now you see last of init of L, a combination of some init or last or basically anything of this has given us some element which in the overall list was neither first nor last. So if we want to find out, let's say second last or something like that, then we can try doing something like this. Now this is where somebody asked about the notion of order, right? This is where the order comes into picture. Let's say the list we have been given. Now this is very specific. We should have been given according to the pseudocode or explicitly that the list is ordered. And in that case, if it is ordered, then this is the way which we can find out the second largest or second smallest element or something. Okay.
Thank you.
So you have to understand the question and the nuance to find out whether it is ordered or not. So read the question. If the notion of ordered is there, then consider it to be ordered. Otherwise, if we are just talking about random piles, then it can be some random order. It does not matter. Okay. Now, in order to see the examples of all these things in too much depth, you can look at the slide of tutorial 5.1. Okay. Or you can just watch tutorial 5.1. All these examples have been discussed in great length here. Now, membership function. Member basically returns true or false. Member L of E, right? So E here can be anything. So there are two possibilities here. If E is in L, then it will give true, else false. Okay. So let's say we have member L, 9. It will give true. But if we have member L, 2, then it will give false. Understood? It basically means whether element E is a member of the list L or not. Okay, so this was basically, yeah, so this is more or less what we have here. If you go through the slides, or rather than the slides, if you go through the videos in which the professors are discussing the cards and everything, you will notice that they have talked about the notion of bookmarks also. What are bookmarks? Why do we need those bookmarks? So those are the kind of things which give you the intuition for why lists were required, because we needed something to be accessed directly. So that is the notion of indexing in a list also. So we can discuss all that maybe in the next class, or you will be able to see the examples in the next class. For now, this was week 5. If you guys want to take a picture of this, please do. After this, in the remaining 15 minutes, I'll discuss some questions briefly. So I will, maybe you guys can take a screenshot of this then, or somebody can send it the chat if possible. So this was the first page, or rather I'll try doing it on from my end and see if maybe to do this. Just give me a second. So this was the first one. Okay. Okay, I'm not able to paste anything here. In the last session, I was able to paste it. Let me save it and then share it with you guys then.
Ma'am, could you share this PDF?
So again, this is not a PDF. I have all of them in the same Excalibur for ease of access actually. So I will share the images of this with you in the chat box. You can save it through that. Okay. So week 5, 1 is there. Let me save all of them together and then I'll share it with you. This was week 2. And again, this will be available on YouTube, so you can access it anytime you want. Week 5, 2 is there. And then we have week 5, 3. Till that, you guys can consolidate your doubts for week 1 to 4 or basically any quiz doubt which you have. Let's see how many I can take in the remaining time.
Ma'am, actually, I have a question
Your
related
voice
to
is
the
breaking.
answer key
Whoever
of
is speaking,
quiz one CP.
whoever is speaking, their voice is breaking a lot. So either write it in the chat box.
No.
Just
Hello.
give me a second. Yeah, just give me a second. Let me attach the screenshots that I have taken to the chat once and then you can take up the doubts. Yeah, are you able to see that? Can everybody please confirm if they can see the chat that I'm sending? The images that I'm sending in the chat?
Yes, ma'am.
Yes, ma'am.
Okay, I'm sending 2 more. So you can download these images from here and I hope that will be clear. Yes. So coming to the questions. Firstly, can all of you guys raise your hands? I'll go by in the order of the raised hands because then everybody will get a fair chance. Okay, so I see a lot of 4 hands raised. So the first one I see is in the order is Sharvakant A.
Set one question number 5.
Can you send the question in the chat box?
Okay, ma'am. Waiting.
Don't write it, try to send the screenshot if possible. Let me see where the chat is. I think somebody has already sent a image in the chat. Sayan Patra, right? Let me try and solve that in the meanwhile. Okay. So A is 1000, while pile 1 has more cards. Read the top card X in pile 1. If X dot shop name is equal to Big Bazaar, then temp is find item X. Okay, if temp is greater than A is equal to temp, move X to pile 2 and find item is maximum price. Card Y has more items. Okay, so what is your doubt in this?
Ma'am, I
Sayan?
guess the increment of initialization of A is also incorrect. So it should be also marked as the correct answer.
Initialization of A is incorrect.
Yeah.
So the question says, can you show what the question is exactly? You can just speak it out if possible. Are you there, Sayan? Sayan, are you there? I'm not able to hear you properly.
Ma'am, I don't think initialization of A is wrong.
Can you
No,
hear
can
me,
you?
ma'am, now?
Yeah, I can hear you. Can you first share what the question is? I can only see the options in the code, but what is it asking? Is it asking the correct statements? Is it asking the incorrect, or select
In
which of the following?
the incorrect initialization or incorrect any line of for the code.
Okay, so for example, in line 17, read an item Z from item list of
I think,
card.
ma'am, line number 18 is incorrect. The if condition.
Why?
Because they want to find the which items has maximum amount.
Have they
So
mentioned anywhere what they want to find out?
yes, ma'am. In the question. Okay,
Yeah,
I.
so can you send the
Yeah,
question once? Yeah, that's
Ma'am, I sent you a screenshot. Can you please check that, including the question?
okay.
For me, like in my answer key, I got A is 100.
So it first of all, everybody getting different things means that you had different sets, right? So that is okay. That is not an issue if you were getting A as something else and somebody else was getting A as something else. That is why the answer, if you see, they are different in different sets. So somebody who has shared me the screenshot earlier, in that line 1 and 17 were different, incorrect initialization of A and stuff like that.
So here in this screenshot, they gave line one incorrect initialization of A, but then here A is 100, which is wrong, no? So this should be.
But the
It
pseudocode
is
may have
incorrect. Like
mistaken.
what
No,
if the least bill
I
amount is
guess there
greater
is
than 100?
three answer should be for it. The line
First of
number
all,
should be also.
can just one person speak at a time, please?
What if the least bill amount is greater than 100? Then this case will not be considered in this case, no?
While pile 1 has more cards, the following pseudocode is using shopping bills. So can you share? Okay, I'll just try to access it from my side. Shopping bills data set. Some information might have been provided to you about the shopping bills data set, right? In the
Yes, ma'am.
No,
beginning.
ma'am. This is the question.
No, in the beginning, in the initial first question or something, right? Some information might have been provided for sure.
But they also have written a note that this is only for reference and does not belong to any question. They gave a disclaimer stating that.
Okay,
And they
okay.
gave just a sample. They did not give the complete data set.
All right. The following pseudocode is
They told this is just a sample reference for a record.
okay. Can you please mute yourself, whoever is speaking? I'm just going through the question. Give me a minute. Meanwhile, whoever is unmuted, please mute yourself if you don't have a question to ask.
Hello, ma'am. Can you hear me, ma'am?
Yes.
Ma'am, I am the first one who sent the first PDF. I can share the question now.
You can share the question in the chat box. Meanwhile, I'm going through already some screenshot that somebody has shared. Once I'm done with that, if it's a different question, I'll come to it. Otherwise, I think most of the students have asked this question itself.
No, ma'am, it is different and the questions also. The one
You
who
can
said
send it in
they
the
are,
chat box. You can send it in the chat box. Because till now, I think I have seen only two separate questions in the chat. Otherwise, it's a similar question sent by multiple people. There is one more question that I see in the chat box, which has a separate pseudocode. It is sent by Sharvakant A, right?
Yes, ma'am. I
Yeah,
have
I'll
doubt.
go through that. I'll go through that.
Yes.
Just let me go through
Okay,
this.
let me know after you go through that.
Yeah, sure. So coming back to the first one. Okay, so the one.
ma'am,
Yeah, go on.
I think the Nambori Radhika Sunanda like that who sent the question like me in Big Bazaar dataset shopping bill. Here A captures the lowest price across all the item purchased. But in my questions, I share you here A captures the highest price across all the items purchased from Big Bazaar.
Yeah, that is what I'm saying, right? Different sets have different problem statements. So not everybody will be getting the same question. Depending on the problem statement, everybody will be getting, depending on your set, everybody will be getting a separate question. More or less, it will be the same, but there'll be some nuances which are different. That is why the concept of sets is there, right? In exam, not everybody is getting the exact same question. The concepts are similar, but some values or some maximum minimum differences are there.
Yes, but according to that, the D option is not incorrect, I think.
Okay, so line 17 in correct conditional statement. The thing is, I'll have to go through all the pseudocodes that you guys have shared, right? I will have to go through them one by one and try to, in order to find out what mistakes are there, I'll have to go through a simulation or a dry run of these on my end. That will take some time, and we are already out of time for the session. I have downloaded all the things that you have shared. I'll go through these questions once. If not, maybe try this course and try to ask this again. If you have already sent the grievances, right? A feedback form must have been shared with you regarding the quiz. So if you have already shared these questions there, then I already have accumulation of those lists, and it is on my task list that I have to go through all of them and figure out if any of the grievances are correct or not. So be rest assured, if the question is not correct, it will be rectified. So don't worry about that. You will get marks if the question is wrong. But instead of trying to solve everything in this particular session, I'll need some time and go through it, go through all the grievances on my own, and we will post an update to you guys soon. Okay? Is that clear?
Yes,
Yes,
ma'am.
ma'am.
Yeah, so till now, I think only two unique questions have come up, right? One is the same question in different sets, and one is the one that Sharvakant shared. Any other questions that you guys have any doubt in? or that you have not filled in a feedback form that you might have received?
So can I fill it in the feedback form?
I'll have to find out where it is. You can also send it on Discourse if needed. You can tag me on Discourse. My ID is @Arshpreet. So you can tag me there in the SETI Discourse forum, which is there, and I'll check that question definitely with the set and the question photo. Is that clear?
Yes, ma'am. Are you
Okay,
going to
so
end this session?
so I was just going to ask whether you had any doubts in the week 5 content that is discussed today. So I've covered more or less everything, most of the things that are discussed in week 5. Only the questions or the complicated examples that can be taken up with effect with the effect from lists are left, which will be discussed in the next session. Next session is also week 5. Just to reiterate once, we discussed why lists are needed, how to form a list, how to append to a list from to the beginning to the end, how to append two lists together, how to use for each, right? We also saw one particular pseudocode example on updating the list and finding the minimum marks. We also discussed some scenarios where lists can be ordered, where sometimes where they can hold no order. But essentially, if a list is already given in an order, we will consider it to be in that order. We will not shuffle it. So dummy list 1 plus dummy list 2, we will not shuffle the order randomly. We will keep it in order. That is important. We discussed nested for each. So for each was a way to iterate through the elements in a list, and we discussed how we can do it in a nested manner, why we can do it in a nested manner. We saw simple code tidbits for this pseudocodes. We discussed what the length of a list is, the first element, the last, the rest, init, member. So these 5 utility functions we discussed for lists. I would suggest you to once go through the content, the video content, for better understanding. The professors are discussing it in a very intuitive manner. And after that, go through the slides once. And if you have any doubt, please ask that in the next session. So ideally, what is expected of you is before the last session of that particular week, you should be you should have already gone through most of the content that is there. Go through the activity questions, do the PAs, do the GAs, and whatever doubt you have till the non-graded part which is there, try to ask that in that last session. Okay?
Yes, ma'am. Ma'am, I am Shahrukh speaking.
Yeah.
Ma'am, that doubt came clear just now. That I only misunderstand that options.
Okay, okay. So again, if you put that in the feedback form, we'll consider it. We'll go through it again once, definitely. But only if it is wrong from our end, we will be posting an update for that particular question.
No, ma'am, it is wrong from my end only. I only put wrong.
Okay, okay.
Just
No
only
worries.
I recognize.
No worries. That's okay then.
Ma'am, is that week 5 deadline is still that 22 only or will be extended?
I think it will be. I'm not sure about the deadlines, to be honest. Those are managed by the operational team. So if it will be extended for all the foundation courses only, then I think it will be extended. But since week 5 had been released earlier only, right, before week 1. So I think.
Ma'am, but the previous class just now are only revision for quiz 1, not thought the week 5, isn't it?
Okay, okay.
Then
I understand your point of view. I understand your point of view. I'll relay your query, but I can't commit on whether it will be extended or not. Okay.
Okay.
So
Thank
any
you.
other conceptual doubts from week 5?
Excuse me, ma'am,
Whatever
I have
we
a
have
doubt.
discussed today. Yes.
Ma'am, I want to know whether while processing in a list, can we have a list of elements which have different data types?
So ideally, when we talk about, I'll have to be honest, I will have to cross check it once in relation to the current CT course which is there. When we talk about lists in Python or in other languages, then yes, we can definitely have different data types in one particular list. That is not an issue because list is essentially a collection of items, right? So we can have that, but in week 5 at least, the content that I have seen, we have not used that. So in future weeks, we have dictionaries first, I think. So I will have to once again go through it on my end also. I can't, surely say something which I'm not 100% sure about. So ideally, if you talk about the concept of lists in general, then yes, they can have different data types. But for our particular course, computational thinking course, whatever we have defined our list to be, for that I need to check whether we can have different data sets or not.
Okay, ma'am.
If you're aware of any other languages like Python, for example, then the list concept in Python, there are multiple elements allowed in that list.
Okay.
But in the examples, at least for this particular CT course, I haven't seen that. I'll have to cross check with the syllabus team once.
Ma'am, can I ask a question?
Yeah, please go on.
Actually, when we are initializing for minimum, we need to set initialize to it large value like
Yes.
larger than the range.
Yes.
It doesn't mean that we know that there is something below the below 100 item price is below 100. That doesn't mean that we will set the minimum in 100. That's we need to set the minimum initialization to the range of the price, like something a big value like 10,000 or 1,000 like this now.
Yeah, so we have to be so this is not no hard and fast rule that what range you have to focus. It's just one comfortable. For example, if we know about marks, right? We know that marks can't be less than 0 unless there is negative marking. We know that marks can't be less than 0. So we initialize it to 0 when we have to find out maximum. When we have to find out
I'm
the
saying
minimum,
I'm saying for minimum. I'm saying for minimum that we need to set a
yeah,
large initialization. So
yes,
I'm saying for
exactly. So when
minimum.
we know that marks are maximum 100, so in that case, even 101 is okay. But at the same time, when we talk about price or something like that, so the upper part becomes a little ambiguous, right? We don't know what the upper thing can be. So in that
Yes.
case, we try to initialize it to a very large value, which is not feasible. So again, there is no surety. Maybe somebody bought something for 1 lakh rupees. That is also
Yeah.
possibility, right? But at the same time, we try to make an educated guess there that okay, since given the data set, given the values that I can see right now, the
Yes.
possibility of getting something greater than this value is very, very less or close to 0. So we will initialize it to this particular value.
Okay, ma'am. I'm saying that I know that there is something which price is near about less than 100, so that it doesn't mean that I will avoid the larger values, larger prices, so that I am initializing it to like 100. It doesn't mean right now.
So if in the given data set, you know that the maximum range is 100 only, that there is no item more than 100, then and you need to find out the minimum, right? So in that case, you can initialize it to 100, and then whatever minimum, once the minimum gets updated, then we don't care about the maximum value we initialized for, right?
Yes,
So if we know, first of all, that okay, some minimum is there, then that is okay.
Yes,
The
yes.
possibility
Some
of
equation
risk
that
is
will
very less.
get under the evolution. So we will get the minimum value after the evolution, but we can't initialize to like depending on that particular price, right?
Yeah, we can't initialize
Okay.
to that. Yeah,
Yes.
yes.
So that if
So if
there
there
is
is any price,
something,
for example, let's say we have 30, 50, 100, and we already know that 50 is a mid value. We have a value less than 50, but we can't initialize it to 50. Ideally, we should be
okay.
initializing it to
Yes,
100
yes,
only.
yes. That's why I'm saying that in my set there is asked to find the lowest price in among all the bills of Big Bazaar. So there is the A is initialized to 100. So that I'm saying that 100 A is initialized to wrong. We should initialize A to a big value like 1,000 or 10,000 like this. So that
Yeah, it depends on the problem statement. I'll have to go through
yes,
it
yes.
once.
Okay.
Ideally,
Okay. My doubt was that yes, yes. Okay.
in the case that you described, right, that if we have 3
Mhm.
values and we know that 100 is there, then we can't use 50. That is for sure. But given the problem statement, I will have to analyze. Maybe it was a typo from there, and I'll have to check. Maybe they meant it to be 1,000 and it was 100, so that might be an issue. I'll go
Okay,
through it
okay.
once and we'll update.
Then I'm saying the summary that if I have something which is value is near about 1,000 or 600 like this, then we need to initialize the minimum value at firstly like 1,000 or more than 1,000. Am I
Yeah.
right?
Yeah,
Okay,
yeah.
okay.
So
Thank you,
whatever
ma'am.
is maximum in the data set, ideally it should be greater than that.
Okay, thank you.
Okay, thank you. I'm closing the session. Hope week 5 is clear to you all. So till for the next session, just go through it once on your own also, and then bring up any doubts that you have in week 5. Thank you, everybody.
Thank you, ma'am.